The CISSP exam involves a lot of memorization, and this video is going to change how you prepare. Had a lot of requests for memorization tips, and I'm going to do you one better. I'm going to show you a series of powerful memorization techniques that I use on CISSP material you actually need to memorize for the exam. This is 20 minutes you don't want to miss. So today I am going to share some memorization techniques that will change the way you prepare for the CISSP exam. In fact, I'm going to cover about a half dozen unique memorization techniques using actual data you need to memorize for the CISSP exam, and moreover, I will show you how to use them together to even greater effect. And I am going to be starting simple and building into the most powerful techniques. I'm, in other words, saving the best for last, so you owe it to yourself to stay with me for just a very few minutes to get through all of this information, because I'm sure it's going to be a big help to you as you prepare. And it all goes well with my Hack Your CISSP exam prep, where I explained how I prepared for the exam in about 2 calendar weeks and passed on my first attempt. You will hear me mention the CISSP exam study guide from Cybex, sponsored by ISC Squared. It is the official reference and a great source of truth when it comes to preparing for the CISSP exam. So let's get right into it. I want to talk about the first mnemonic device. This mnemonic device is also known as a memory device. It's a learning technique that makes memorizing information easier. And a really common technique is called an expression mnemonic, or sometimes just referred to as an acronym, where we take the first letter in a series of words and we create a memorable phrase. So, really the best mnemonic devices are simple, they're relevant to the topic for which we're creating them, and if we can make them visual, that's even better. And I'm going to show you examples of all of these. In fact, let's start with something fairly simple, a first letter mnemonic. And we're going to start with something you need to memorize for the CISSP exam, and that is the OSI model. I'm sure you've heard of this. It's been around for a very long time. It shows up in domain 4 of the CISSP exam content. And it's a 7-layer model starting at layer 1 with the physical layer, and then data link, network, transport, session, presentation, and application. So we'll take those 7 letters, P, D, N, T, S, P, A, and we're going to create a memorable sentence. So let's, since this is not a process framework, we could really do this in either direction. So let's do it in both directions. So we'll go from the bottom up. Please do not throw sausage pizza away. That phrase has been around for a long time. When I was first learning network basics, I saw that phrase back in the 1990s. And if we go the other direction, all people seem to need data processing. This one is a little more relevant to the topic, right? That one on the left is pretty memorable, though. So take your pick, but you've got a couple of good examples. And to be fair, you need to know a fair bit about the OSI model in terms of at what layer do different protocols live? For example, at the physical layer where we're talking about the network, you have things like DSL and ISDN. And then layer 2, MAC and ARP, which we use to get our MAC addresses. IP protocol, network address translation, RIP routing. Transport, we have TCP and UDP. At session, we have server message block and RPC. Presentation, TLS and SSL are good examples. And application layer, we could do SSH and HTML. So that first letter mnemonic is really powerful. It's better if the phrase is relevant to the topic. So let's tackle another framework you need to remember for the CISSP exam, and that is change management. So this also comes up in domain 7. And change management is a 6-step process, which is request the change, review the change, approve or reject, test the change, schedule and implement, and then document. So we have RRATSD. And here's a great and very relevant first letter mnemonic, I think. So we'll take that and turn that into a phrase we can remember. And that is, Richard rarely approves the scheduled deployment. So what are we approving with change management? We're approving implementations, deployments. So very relevant to our topic, which makes it an even better memorization tool. And I love this next one. So a Picmonic combines the first letter technique with a relevant image to improve recall. And I have the perfect example for you here. I'd love to say that this was my idea, but it was not, but I still love it. So for the incident management framework, which is called out in domain 7 in the guide and called out in the exam essentials, you have a 7-step process: detection, response, mitigation, reporting, recovery, remediation, and lessons learned. So the acronym is DRMRRRL, which when pronounced sounds like drum roll. It's not spelled exactly like drum roll, but it's really easy to make that mental connection when we put that with a picture of a drum roll. And I'm cheating a bit there. That's an animated GIF, right? So that's an animated picture, which does the job even better. So, like the OSI model and change management, you do need to know something about the framework. So, for example, in incident management, detection is about identifying the incident. Response is about triaging and ensuring we really have an incident, so making that decision to declare. Mitigation, so step 3, correcting and containing the issue. Then reporting the issue to relevant stakeholders, customers, legal, regulatory, law enforcement in serious situations. Returning to normal operation, recovering. And then remediation is where we address root cause. So what actually caused this, and with remediation and lessons learned, making sure we take steps to prevent recurrence of the issue and to improve our incident response. But drumroll, I think, is a great acronym for it. So reporting and recovery may come up on the exam as being management decisions. That's called out in the guide, so just make a mental note of that. But remember, drumroll. Is your frontline support struggling with too many Microsoft Cloud portals? Now they can manage Office 365 users and devices directly from Microsoft Teams using Simon, the AI-powered chatbot for the Microsoft Cloud. A link with more info in the video description. All right, next, we're going to talk about chunking. So chunking is a very powerful technique because we use chunking with really big topics to break them into smaller pieces that make sense. And there's no better candidate on the CISSP exam than cryptography. Big topic, lots to remember, lots of numbers. So let's chunk it. So cryptography, we have lots to memorize here. We could break that down into asymmetric algorithms, symmetric, hashes, block ciphers, just to name a few. So why don't we take a swing at hashes? And what I love about chunking is I can now take this chunk that is hashes and I can break it into manageable parts. So I can chunk the chunk, so to speak. So let's do exactly that with hash algorithms. So I'll start with the message digest family. So I have MD2, 4, and 5. And what I notice here right away is that their hash length is the same across the board. So since I've broken this into just that MD5 family, I now see the MD family. I have an easy memorization task here because they all share a common hash length. The other thing I notice is none of those are still in use. They're actually all superseded by MD6 and other protocols out there. So let's apply that trick to the SHA family. So SHA is secure hash algorithm, and we're going to find some similar simplifications here in terms of memorizing. So what I notice right away with the SHA family is when I look at their hash lengths, I notice that for all of the SHA algorithms that are in use in this chart, that the hash length matches the number in the name. So SHA-224 has a hash length of 224, and on down the list. In fact, the only one that doesn't have that characteristic is SHA-1, which has 160 length, but you'll notice it's not in use anymore, right? So a couple of simplifications there, and you're going to want to apply this to the other chunks of cryptography. It's definitely coming up on the exam. You'll definitely want to have these committed to memory, but you'll also want to understand their function. So let's switch gears and talk about software development security. I want to talk about domain 8, and we're going to take a look at the ACID model, which refers to database transactions. So the ACID model: atomicity, Consistency, isolation, and durability. So the property of atomicity means to be atomic, meaning all or nothing. The entire transaction must succeed or else roll back. Consistency means our transactions start and end with a consistent database. If we have a database in an inconsistent state, we're not going to trust anything we read from it or that anything we write to it will maintain integrity. Isolation. Transactions operate separately from one another. Transactions are logged to varying levels. And then durability. Once committed to the database, transactions must be preserved. And so if we take ACID, the acronym for the first letter in each of those words, we could do a simple one here. All cats incite dogs. Everybody knows cats hate dogs. This is an easy one for me to remember. But maybe we want to step this up a notch, and we want to remember that our best mnemonics, our best memory devices are simple. I think this meets the simple criteria, but they're also relevant and sometimes use pictures. So let's shoot for relevant here. How about analyst can interpret data? That's very relevant to database transactions. It's something a DBA would do, right? So now let's talk about the ideal model in software development. So the ideal model is in domain 8. It's a 5-step model that includes initiating, diagnosing, establishing, acting, and learning. So ideal is my acronym there. And I'll say I do every analysis live. And again, this is one that's called out in the exam essentials that you should know for the exam. So initiating, the process of providing business reasons behind a software change, diagnosing the need for changes, looking at the current state, establishing our plan of action, acting, so basically developing, testing, refining, and implementing our solution, and then learning by analyzing the results and proposing new actions to take that next step, similar to kind of lessons learned in incident management, right? There's another software development model, and that's the software capability maturity model. Also 5 levels, and they're actually called levels 1 through 5, and they are initial, repeatable, defined, managed, and optimized. So IRDMO, how about I read data maps online? So the software capability maturity model, we have initial, which is people developing software with little or no process, right? Just everybody acting on their own with no real orchestration. Repeatable. This is where we have basic life cycle management processes, and then moving into defined, where developers operate according to a set of formal processes for software development, documented processes. Managed, we have quantitative measures that are utilized to gain a better understanding of the development process and how we're doing. And then optimized, where we have a process of continuous improvement that occurs, including a feedback loop. So software capability maturity model, another you'll need to know for the exam for sure. But again, I read data maps online, a good way to commit this one to memory. Now you can actually combine these techniques for even more powerful results, and I have the perfect place to do this. We're going to take a look at security models, which come up in domain 3, and I'm going to show you how to combine 3 techniques in memorizing information around security models. So security models, simply put, explain how access and security controls can be implemented. But I'll start by chunking. So I'll divide security models into models that focus on integrity and those that focus on confidentiality. So I'm chunking here. So on the integrity side, we have the BIBA model. We have Clark-Wilson, Goguen-Messeguer, the last names of the 2 people behind it, and then the Sutherland model. On the confidentiality side, we have Bell-LaPadula, Brewer and Nash, and Take Grant. Now I want you to notice a couple of things here about what I've chunked into these 2 categories. So I've called out a unique property of each. So you notice BIBA, for example, I say is a state machine model. Clark-Wilson implements what's called an access control triple. We have the non-interference model. The Sutherland model is focused on preventing interference. Brewer and Nash, aka the Chinese wall. So I'm trying to call out a unique element that helps me to associate the function with the name. And you definitely have to go deeper in these, and we will do that together in the core lesson around domain 3, which is coming here in the next few days. So with Bell LaPadula, I tend to add one little memory aid there, and that's that Bell LaPadula is used by the government, by the Department of Defense. On the integrity side, if you get a question around security models and it mentions integrity specifically, I'm going to lean pretty heavily toward Clark Wilson being the probable answer, just based on commonality of its use in the world. But that's just the first step. So now we're going to employ some other techniques in the world of security models here to aid our memorization. So let's look at Bell LaPadula. So how we'll sort of leverage additional controls, additional memory aids to help us here. So Bell LaPadula, the first thing I notice is the word bell in the name. So I'm going to start with a Picmonic. I'm going to start with a bell. And I have that bell there for a reason. So the phrase I had right below Bell LaPadula was no read up, no write down. So I imagine no read up going up one side of the bell and then going down the other side of the bell, no write down. In case you're curious, no read up in this model means that you're not allowed to read data that sits at a higher level of classification than the one for which you're approved, and no write down means you're not allowed to down classify data either. In other words, to take classified data and reclassify it to a lower level. Now you'll notice I've highlighted the first letter of each of those words because I'm also going to use a third method, and that's an acronym or a first letter mnemonic. No running under nets with dingoes. And I use that because it's unusual. Dingoes is a very unique Australian dog type species. All right, and another really powerful technique that's going to be super important, and that is repetition. So you really need to understand not only that repetition is important, you know that, but how much repetition and how frequently is the right amount. So the research here has been done. So let's talk about that, and I'll tell you how I do this when I'm preparing for an exam and what I did in those 2 weeks. So we're going to use a method here called spaced repetition. So this simply means we perform a memorization exercise, and after you perform an exercise, your memory is going to fall off. This is called the forgetting curve. So what you'll find as we move along in a second memorization session and a third is that our recall gets a little better and the forgetting curve gets longer and shallower with repetition. And we're going through that spaced repetition. So the $1 million question is, how long should I wait between those sessions? So here it is. So if you want to remember something quickly, your first 5 memorization passes would be right after learning, then 15 to 20 minutes, then 6 to 8 hours, then 24 hours, then 48 hours. So you're doing 5 passes in a single 2-day period. And if we want to remember for a longer period of time, we need to commit to long-term memory. So here, we'll space out those repetitions just a bit. So starting with right after learning, then 20 to 30 minutes, then you notice after a day, and then 2 to 3 weeks and 2 to 3 months. So there's a big difference here, and neither of these suited me just right. So what I did was kind of a modified memorize quickly strategy. What I did was took roughly what you see there in those passes, those first 5 passes, and I added a 6th repetition that I did at the end of a week, and then again at the end of 2 weeks, right before I went into the exam. So I was kind of bridging the gap between memorizing quickly and memorizing for a long time by adding additional repetitions at the week mark. So kind of the best of both worlds in that respect. And one other thing to really focus on here, and this is true of anything you memorize, not just for the CISSP exam, but for any exam, and that is around memorizing versus understanding. So studies show that understanding a concept before you memorize greatly improves retention, meaning I understand the concepts and I can use the information to solve problems or answer questions. And at the end of the day, isn't to solve problems or answer questions really what we're out to do? We're out to implement what we know. As you're going through this memorization, definitely make sure you get the CISSP official study guide. It has 1,300 practice questions, but it also has 700 flashcards, which are fantastic for memorization. I prefer to have a live partner to quiz me. If you don't have a live partner, though, you have the flashcard, so it gives you the convenience of being able to do that whenever you like. And it's got the searchable key terms. You can get it with the link in the video description. Do you have a memorization tip that's worked well for you in exam prep? I'd love to hear about it, and I'm sure many other people would too. Tell us about it in a comment below the video. And those are my favorite memorization techniques for improving your memorization efforts as you prepare for the CISSP exam. We have a lot more coming in our CISSP exam cram series, so make sure to subscribe, like, and hit that notification bell so you get a heads up every time we drop a video. Until next time, be well, stay safe, and take care.